Page number 28, question answers. Question number 1. Which separation techniques will you apply for the separation of the following? A. Sodium chloride from its solution in water. B. Ammonium chloride from a mixture containing sodium chloride and ammonium chloride. C. Small pieces of metal in the engine oil of a car. D. Different pigments from an extract of flower petals. E. Butter from curd. F. Oil from water. G. Tea leaves from tea. H. Iron pins from sand. I. Wheat grains from husk. J. Fine mud particles suspended in water. Answer. A. Distillation or evaporation. For B. Sublimation. For C. Filtration. And for D. Chromatography. E. Centrifugation. F. Separating funnel is used. G. Filtration process is used. H. Using a magnet. I. Blowing air or winnowing. J. Loading and sedimentation. Question number 2. Write the steps you would use for making tea. Use the words solution, solvent, solute, dissolve, soluble, insoluble, filtrate and residue. Answer. Take some amount of water in a pan and heat it over a gas stove. Now add some tea leaves, sugar and boil it. In this case, water acts as solvent and tea and sugar as solute. After the mixture becomes brownish in color, add small amount of milk and remove it from stove and filter through a tea strainer. The caffeine present in tea gives the color after being dissolved in hot water. On filtering, the soluble part passes through the strainer while insoluble part remains in the strainer. That is how we can separate the filtrate tea and the residue tea leaves. Question number 3. Pragya tested the solubility of the 3 different substances at different temperatures and collected the data as given below. Results are given in the following table as grams of substance dissolved in 100 grams of water to form saturated solution. Substance dissolved, temperature in Kelvin, that is at 283, 293, 313, 333, 353 solubilities are given. Substances dissolved are potassium nitrate at 283.21, 293.32, 313 Kelvin 62, 333 Kelvin 106, 353 Kelvin 167. Sodium chloride 36, 36, 36, 37, 37. Potassium chloride 35, 35, 40, 46, 54. Ammonium chloride 24, 37, 41, 55, 66. A. What mass of potassium nitrate would be needed to produce a saturated solution of potassium nitrate in 50 grams of water at 313 Kelvin? B. Bragya makes a saturated solution of potassium chloride in water at 353 Kelvin and leaves the solution to cool at room temperature. What would she observe as the solution cools? Explain. C. Find the solubility of each salt at 293 Kelvin. Which salt has the highest solubility at this temperature? D. What is the effect of change of temperature on the solubility of a salt? Answer. A. Solubility of KNO3 at 313 Kelvin is 62 gram. It means 62 gram KNO3 potassium nitrate is needed to make saturated solution of potassium nitrate in 100 gram of water. So, to make saturated solution of KNO3 in 50 gram of water, 31 gram of KNO3 is required. B. Bragya observed that on cooling the saturated solution to room temperature, the solubility of KCl, potassium chloride, decreases and some crystals of KCl get separated. This happens because the solubility decreases with decrease in temperature. C. Solubility at 293 Kelvin. Potassium nitrate 32 gram in 100 grams of water. Sodium chloride 36 gram in 100 grams of water. Potassium chloride 35 gram in 100 grams of water. Ammonium chloride 37 gram in 100 grams of water. So we can suggest from this data that ammonium chloride has maximum solubility. D. Generally, the solubility of the salt increases as temperature increases. However, different salts have different solubility at different temperatures. Here, in this solubility test, the solubility of KNO3, potassium nitrate, increases appreciably, but the solubility of sodium chloride remains almost constant. Colloid. Colloids are heterogeneous mixtures in which particle size 1 to 100 nanometer or 10 power minus 9 to 10 power minus 7 meter lies in between those of true solutions and suspensions. Since their particle size is small, they cannot be seen with naked eye. However, their particle size is big enough to scatter light. Suspensions are heterogeneous mixtures. These consist of materials that are insoluble in a solvent and have particle size big enough to be seen with the naked eye.